We're going to begin our study of precalculus with trigonometry. You might recall learning about trigonometry in geometry class and how the angles of a right triangle relate to the ratio of its side lengths. Okay, something like sine of theta would give us the ratio of the opposite to hypotenuse. Cosine theta would be adjacent to hypotenuse. Tangent of theta would be opposite over adjacent. Okay, in geometry, right triangle trigonometry is a powerful tool that's allowed us to solve many problems and has many real-world applications, such as finding the height of a tall object, like a building, without actually having to climb up to the top. Okay. In this course, we're going to expand our understanding of trigonometry to angles beyond those simply found in right triangles. We'll take our trigonometric functions to the coordinate plane. So we're going to build a trigonometry that exists on the coordinate plane and build a circle that will allow us to calculate trig functions on any angle, not just these acute angles of right triangles. So I could have some angle here that was even 150 degrees, and I could do trig on that. So I could do, say, sine of 150 degrees, and it would produce some answer, even though in the context of a right triangle, that wouldn't make as much sense. This is going to become an incredibly powerful tool, and it's going to have numerous applications. We can do things like model rotation. Because we're on a circle, we can model rotation around things like a planet orbiting the sun. Or it could be the rotation of a tire turning, a wheel on a car turning around. Or cyclical motion, like waves, any sort of waves. Business cycles, and we can even do things with like complex numbers, imaginary numbers. So we can build a system where we can use trigonometry to calculate complex numbers. So how are we going to expand our understanding and build this system? First, we're going to need to develop some ideas, definitions, and terminology on the coordinate plane. Notably, trigonometric functions are functions of angles. Okay, it's all about angles. So we're going to need to define what an angle is and think about how are we going to define an angle on the coordinate plane. We're going to choose a standard position for locating virtually all of the angles we want to deal with, and we're going to go from there. So first of all, recall from geometry that an angle is defined as the space between two intersecting lines or surfaces. And for our purposes, we're going to think of the angle as having a vertex and being built from some initial side and a terminal side. And note that those sides are actually rays in this point, or in this case, but we'll refer to them as sides. And then the angle is kind of the measure of that space in between. Okay. So we could say that this angle could exist on a coordinate plane. So I'm going to draw in a little coordinate plane here. Right, and I could draw an angle anywhere I want on this coordinate plane. But if I want to have a standard position for an angle on the coordinate plane, and we want to use that to build this system with really powerful applications, where should we pick to be our standard position? Where should we locate our angle? Well, we're going to place the vertex of the angle on the origin. It seems a natural place. And we're going to fix our initial side to the x-axis. So the initial side is going to go on the x-axis. The vertex is going to go on the origin. And that's going to allow us to figure out where is the angle going to go based off this initial side and with the vertex on the origin. Okay, we need to choose a direction to go for positive angles. So I'd either want to go this way and call this some positive angle, maybe that's 120 degrees, or I would want to go the other direction and call that a positive angle. Which one do you think is going to make more sense? It's actually going to be counterclockwise that we choose to define as a positive angle. So a counterclockwise angle we consider to be in the positive direction. Say this was a 50-degree angle. We would say that the terminal side is up here. Okay, and we will say counterclockwise is the positive direction of an angle in standard position. Okay, so that's really important. When we describe an angle in standard position, we think of it as starting on the initial side and then rotating through space to come to our terminal side. And so we can define that rotation as being positive, or positive 50 degrees of angle, if we go counterclockwise. And the reason is because that puts us in the first quadrant, right? Here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now in quadrant 1, we have positive x and positive y coordinates. So by rotating counterclockwise with our angles going in the positive direction, our first set of angles end up in the positive quadrant, which is kind of nice. Quadrant 2 is negative x, positive y's. Quadrant 3 is negative x, negative y's, and quadrant 4 is positive x, negative y's. So by calling positive motion counterclockwise, we initially land in this positive quadrant. So all the first set of angles we would deal with, like 1 degree, 2 degrees, all the way to 90 degrees right here, we'll all deal with positive coordinates. So that's kind of part of why we might define counterclockwise as being positive. Okay, so to recap so far, an angle in standard position, so standard position of an angle on the coordinate plane, okay, and technically this is a rectangular XY plane, but for now we'll just refer to it as the coordinate plane. We say the vertex is on the origin, 0, 0. Okay. We say initial side is on the x-axis. The terminal side, terminal like the word terminate, terminator, right? It means to end. So the place where the angle ends, the terminal side, is the end of the angle, is the end side, can be anywhere. We consider positive angles are counterclockwise from initial to terminal, and negative angles are clockwise. Okay, so if I wanted to describe this angle, maybe I go this way, right, and describe some angle, I could describe that as negative 50 degrees. Interestingly, so something to note here is that negative 50 degrees or 50 degrees is not the only way I could describe those angles, or at least not describe the position of the side. So let's come down a second and let's build another coordinate plane. Okay. And I'm going to fix my initial side such that my angle will be in standard position, initial side, and then I'll build a 120 degree angle. And I'm just sort of estimating here, but let's call this angle 120 degrees. And here's my terminal side. Okay. I could also describe this angle as being negative 240 degrees. So that would be referring to the clockwise rotation from my initial side to my terminal side. Note that it gets me to the same place, but it describes a different idea of how to get there. And even beyond this, we can actually come up with more numbers of degrees that land in the same place. So if I think about one full rotation, well, that would be 360 degrees. So if I do a 360 degree rotation and I build my terminal side here, I would have 360 degrees. But note that that's the same as 0 degrees, right? That would be the same angle, or 360. Or if I did 2 full rotations, right, that would land me on the same point. Let's clear some space here. Or if I did 1, 2, 3 rotations, I would end up on the same point. So all these multiples of 0, 360, 720 are going to land me at this same location. Or if I go the other direction, if I go negative 360 degrees, okay, a negative 720, right, those sort of describe the same point. And what we're going to call these are coterminal angles, okay? So angles that are coterminal are going to be angles that have the same terminal or position, same terminal position of the terminal side. But be careful to say that they're the exact same angle, okay? A coterminal angle is an angle in standard position that shares a terminal side. They are in the same terminal position / share a terminal side. But the path to get there is different. Okay, so if you imagine, let's say an angle of 10 degrees, right? Let's pretend that's 10 degrees compared to an angle of 370 degrees, right? Turning your body 10 degrees versus turning your body 370 degrees, you'll end up in the same place, but you might get a little bit more dizzy doing 370. So you get to the same terminal location, but the path carved out to get there is going to be a little bit different, okay? And so we can kind of generalize this idea, okay? Generalizing coterminal angles. So if I want to generalize coterminal angles, say I had an angle such as 20 degrees. And let me clear some space on this, right? Oop, that didn't go so well. Actually, whatever. Let's just make a new graph. We'll put all that back. Okay, so if I want to generalize coterminal angles, and here I have my coordinate plane. Okay, say I have an angle of 20 degrees. And I want to know what's the next angle that's going to get me to that same terminal side. Well, if I just go another full rotation, right? If I rotate 20 and then do another 360 degrees from that 20, I'm going to get my next location, which is going to be 380 degrees. So 20 and 380 are coterminal. Then if I want to go another 360 degrees, another full rotation, well, I'm going to get to the same spot, right? I can go around again. So 380 plus 360, I believe would be 840. Actually, that sounds way too big. 740. There we go. Okay. And I could keep doing this process, or I could go in the other direction. I could go the other way and subtract 360, and I could go in the other direction. So then I would end up at negative 340 degrees. So if I start here and go 340 degrees clockwise, I'm going to land at that same relative location. So if I want to have the general form of all set of coterminal angles, okay, I could say x degrees plus 360k degrees, okay? Where, and this is k belongs to the subset of integers, okay? So this right here means, let's take this all over here. Don't really want that, okay? So this just means any angle x plus 360k, where k belongs to the set, and this is of integers. So that little z belongs to the set of integers. So if we have some angle x and we add 360 times k, well, the set of integers means k belongs to this set of we'll say -2, -1, 0, 1, 2, so on and so forth. The integers are just sort of like all those whole numbers, positive, negative, including 0. So long as k is an integer, 360 times k is going to represent 1 full rotation, or 2 full rotations, or 3 full rotations, or -2 rotations, rotations in the other direction. So we would be able to say that all those coterminal angles are covered by that expression. Okay, so I'm going to give us one little example here, another one. So say I give you an angle of 120 degrees, and say we want to graph this in standard position. So I'll draw my axes. Okay, I'll draw my vertex on the origin. I'll draw my initial side. Then I'm going to kind of estimate 120 is probably 2/3 of our way here, right? Half a turn would be 180. This would, that's interesting. Full turn would make 360. So 120 is probably somewhere around there. So there's 120 degrees counterclockwise. But if I wanted all coterminal angles, okay, the set of coterminal angles with 120 degrees, I could write that as 120 degrees plus 360k, where k is an integer, and that just means belong to the subset of integers. Okay, k belongs to the set of integers. I'll just write that k belongs to the set of, and that's integers. So it means k is an integer, basically. And that means that this describes all of our possible angles, right? We could have 120 plus 360 times 1, which would be 480. We could have 120 plus 360 times 2, which would be 600. Actually seems too low. Which would be 800. We could have, actually, why? Mental math is struggling, which would be 840. We could have 120 plus 360 times 0, which is 120, right? And you'll notice each time we're just adding 360. So we're getting one more full rotation. Or we could have 120 plus 360 times -1, which is equal to -240, and so on and so forth, right? We're putting in k values that are integers because we're saying any angle 120 plus 360k is coterminal to 120. It's going to describe the same angle, just with a different number of rotations. But we'll still always land here, no matter if we go there or 1, 2, so on and so forth. Okay, so that is basically the main ideas we want to cover in this first lesson. So I'm going to do a key ideas summary, and then that'll wrap up this video. So key ideas summary. Okay. Key idea number 1. We can represent angles in the coordinate plane. Okay. We describe these angles with an initial side and a terminal side. Okay. A positive angle corresponds to counterclockwise rotation between the initial side and the terminal side. So So if I have my initial side, terminal side, positive angle. A negative angle corresponds to clockwise rotation between the initial and terminal side. So if I have an angle, if I have an angle maybe like this, right, that would be negative. But I could also have that exact same angle as before and describe this part of it as angle, but that would be considered a negative angle. Okay, so those are some key ideas. Let's keep this under the theme of angles. And then one more. An angle is said to be in standard position, key term here, if its vertex is on the origin and its initial side is on the x-axis. We're basically exclusively dealing with these, at least for the time being. We can say 360 degrees corresponds to one full rotation. Okay. Angles can be greater than 360, and it just means that we have more than one full rotation. So, and are considered as more than one full rotation. Okay. And then our last key concept here, coterminal angles share, and we'll say actually coterminal angles, we'll say in standard position, share an initial and terminal side. Okay, so for example, 10 degrees and 370 degrees on the coordinate plane would look very similar. 10 degrees would be here. 370 would describe, 370 would describe the same angle, but it would be more than one full rotation. Okay, and to that idea, coterminal angles, or I should say, though coterminal angles occupy the same location, they have different measures. Okay, so we can think of the angle as thought as rotating a ray that many degrees. And though you end up in the same space, the path there is different. And then the general form in degrees would be some angle x degrees plus 360k degrees. Creates coterminal angles where k is an integer. Okay, so hopefully that was a useful video bringing the first set of main ideas here. All about angles in the coordinate plane, putting them in standard position. And this is going to help us work towards building a whole system of trigonometry on the coordinate plane where you can do trig with angles that are not just acute in a right triangle. And it's going to be really, really, really powerful with the things we can model with this. So hope you enjoyed. Thanks for watching.